Alright. Okay, so for number 1, 5 and 7. 5 and 7 are both in the top right, so those are corresponding angles because they're both in the same position. 3 and 13, if we cover up this bottom one, 3 and 13 are on different sides of C, but they're outside, so they're alternate exterior angles. 1 and 2 are right next to each other. That's called a linear pair. Bless you. 7 and 9, they are on different sides. So if you have to, just turn the paper. They're on different sides of the transversal, and they're in between the two lines. So these are also alternate exterior angles. 2 and 3, they're on the same side, and they're inside. So that's same side interior angles. 13 and 15 are both in the top right hand, corresponding angles. 1 and 7, they're right across from each other. That's just your regular old vertical angles. 3 and 7 are on different sides of the transversal, but they're in between the two lines. So that is alternate interior angles. Oops, earlier I said 7 and 9. Those are interior. I don't know why I put an E. Alright, 13 and 9 are on opposite sides, but they're outside, so those are alternate exterior angles. And 5 and 12 are both on the same side of C, and they're in between the two lines, so those are same side interior angles. Now for these problems on 11, 12, and 13, if A and B is parallel, and I'm looking at angle 4, I'm not looking at all at D. So you can get a Post-it or a sticky note, or you can get something and completely ignore that bottom part. So if we know 4 is 103, what else is 103? Well, 6, 12, and 14 are also. So angle 6, angle 12, oops, and what did I say? Angle 14 also equal 103. So what would my other angles equal on that? Well, if they're a linear pair, that would be 77. So angles 3, angle 5, angle 11, and angle 13 equal 77 degrees. Now C and D are parallel, and I'm giving you angle 7. That means you don't need to worry about that. So if 7 is 49, then so is angle 1, because that's vertical angles, and angle 5, because that's corresponding, and angle 3 are also 49 degrees. Now what's the linear pair with that? 180 minus 49 is 131, would be all the other angles. So angle 2, angle 8, and their corresponding angles, angle 4 and angle 6 equal 131 degrees. Now if everything's parallel to it, then all the corresponding angles match with it. So for 13, anything that is corresponding with 13, because all of them are parallel, will also be 83 degrees. So that's going to be angle 11, angle 15, angle 9, angle 1, angle 7, angle 3, and angle 5. All of those equal 83 degrees. And I'm not going to list them out, but all others equals 97 degrees. Do I have any questions on 1 through 13 if anybody's paying attention? No. Okay. All right. For number 14, I'm telling you angle 7 and angle 11. What do I know if they're all parallel? What do I know about 7 and 11? Those are corresponding angles, so they are congruent. So 7x plus 19 equals 9x minus 3. If I do the math, I get 2 equals 2x. So what does x equal? 11. Now I want to know angle 9 and angle 5. Well, angle 9 is just like angle 7 because they're corresponding angles. So I can just plug into 7. And my angle 9 is 96 degrees. For angle 5, that's going to be, compared to 11, that's the linear pair with 11. So remember, 11 and 7 are the same, so I can just subtract that from 180, and angle 5 will be 84 degrees. Any questions? Are you sure? Okay. Angle 2 and angle 5, is that what it says? Angle 2 and angle 5, those are same side interior angles. So they're going to be supplementary. So I'm going to add them together and make them equal 180. I then get 9x minus 9 equals 180, and 9x equals 189. When I divide, x equals 21. Now I want 4. 4 is going to be corresponding with 2. So if I plug this into 2, I get 71. So the measure of angle 4 is 71 degrees. 8 is a linear pair with 2. So I can just subtract from 180, and I get angle 8 is 109 degrees. Alright, for 16, if angle 6 and angle 9, 6 and 9 are alternate exterior, so those are congruent, so I can set them equal. I have x is an x squared, so I need to make it equal 0, so I'm going to subtract 8x, subtract 14, and I get x squared minus 5x minus 14 equals 0. Multiples of 14, negative 14 that give me 5 would be 7 and 2. And I want negative 5, so it's going to be negative 7, positive 2. So x will be positive 7 and negative 2. Now I want angles 7 and 12. Those are both the linear pairs of 8 and 6. So let me find real quick what 8 is. Let's do 8 because I think it's easier. 8 and 7 plus 14 gives me 70. So that's what angle 8 is. So to find the linear pair, I subtract from 180. Oops. And I get 110. So angle 7 equals 110. And if I did negative 2, it wouldn't work, so I'm going to cross it out. It'd give me a negative answer. And remember, 7 is, ooh, why is that not working out in my head? Oh, I'm lying. I was thinking we were doing 8. We're doing 9. Sorry, that's the linear pair. That's for number 12. That's for 12. That's the linear pair. 7 is actually corresponding with 9, so it should be the 70. Alright, for 5 and 8, 5 and 8 are alternate interior, so they're also congruent, so I'm going to make these congruent. So this one's actually a little bit different. because I don't have an x, y'all might want to pay attention to this. This one's different because I don't have an x, so I'm just going to get my squareds on one side and my numbers on the other. So I'm going to minus 2x squared and add 19. I end up getting x squared equals 49. I don't need to make it equal 0 in this instance because I don't have an x. What would I do now? Square root it. So what is x going to equal? 7. Now I want to know what 2 is. 2 is a linear pair with 8. So I plug in my 7. That's what I get. So it's a linear pair. So I'm going to minus from 180. So angle 2 equals 52 degrees. 11 is also a linear pair, so it's going to be the same thing. All right. 8 and 9. 8 and 9 are same side interior angles, so they're going to be supplementary. So, ooh, this is going to be a lot. I'm going to add these together. Are you cool with me doing that beforehand? 3x squared minus 3x plus 12 equals 180. And then I got to get, there's an x and an x squared, so I have to subtract 180. So I get 3x squared minus 3x minus 168 equals 0. They all can divide by 3. So when I do that, divide them all by 3, I end up getting x squared minus 1x minus 56 equals 0. And now, what multiples of 56 can give me 1? 7 and 8. So I want a negative 8 because it's a negative 1 and a positive 7, which gives me x equals negative 7, positive 8. When I go back, I want angle 4, which is going to be congruent to angle 9 because they're vertical angles. So I'm pretty sure the negative 7 doesn't work. So I'm going to go ahead and do 8 squared. That gives me 41 for angle 4 degrees. And then for angle 5, those are same side interior, so I just need to subtract from 180, and I get 139. All right, next we're going to be graphing lines. So in order to graph lines, we have to make them y equals. So for this first one, we are going to, I'm going to rewrite it down here. And I'll see that. Okay. 4x minus y equals negative 7. I'm going to move the 4x. So I'm going to end up getting, all right, and then I get negative y, don't forget to bring down that negative sign, equals negative 4x minus 7. Now y is not by itself, but I can easily just change the signs on everything and make it positive 4x and a positive 7 because I changed it to a positive y. So when I graph that, 1, 2, 3, 4, 5, 6, 7, okay, that's not very helpful. I'm going to be going up 4 to the right 1, but if I go up and to the right, that goes off my page. So I can go, let's see, 1, 2, 3, 4, 5, that's 5, 6, 7, okay. So if I go down 1, 2, 3, 4, backwards 1, down 1, 2, 3, 4, backwards 1, that still works. Now for my next one, I have x plus 4y equals negative 12. When I convert that, y equals negative 1/4 x minus 3. So I'm going to go to the 1, 2, 3, negative 3. And it's negative 1/4, so I'm going to go down 1 over 1, 2, 3, 4. I can't go anymore, so I'll go up 1 backwards, 1, 2, 3, 4. Now, how can I tell if these are parallel, perpendicular, or neither? Well, I can look at their slopes. Oops. I have a slope of 4 and a slope of negative 1/4. They're definitely not parallel. But they are opposite reciprocal, so these are perpendicular, and that's the sign for perpendicular. Okay, next one, getting y by itself here. I have 3x minus y equals 4. Don't forget to bring down that negative y. That's a positive 4, but I'm going to change it all. Change all the signs. So I start at negative 1, 2, 3, 4, and I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. For the next one, got to get y by itself. I'm going to divide by negative 2. A negative divided by a negative gives me a positive. So I'm going to begin at 1 and go up 3 over 1. Can't go anymore. Down 3, backwards 1. And because both of these slopes are the same, and because I can look at it and tell, these are parallel. And that's the symbol for parallel. Alright, halfway done with the next practice. Turning it over. Use a different color now. For C, I have x, can you see that? Minus y equals negative 5. I can change all the signs. So I'm going to begin at 1, 2, 3, 4, 5. And this is a positive 1 as a slope. So I would go up 1 over to the right, but I can't because it's done. So now I'm going to go down 1, backwards 1, down 1, backwards 1. For the next one, it's already y equals, so I can start at negative 1. And the slope is negative 5, so I'm going to go down 1, 2, 3, 4, 5 over 1. That kind of goes off of it. So now I'm going to go up 1, 2, 3, 4, 5, backwards 1. Now they're definitely not parallel, but if I look at my slopes, negative 5 and 1, they're not the same and they're not flip and switch. So this is a neither. Y equals negative 3, that's hoy. So I'm going to go to the y, go to negative 3, and draw a horizontal line. X equals 6, that's buck. So I'm going to go to my x, 1, 2, 3, 4, 5. It's kind of off the page. And that's going to be perpendicular, because a horizontal and a vertical line are perpendicular. Okay. For 20, it says write an equation given in the given form for each of the following. So I want a line with this slope that contains point slope form. Now remember, point slope form is y minus y1 equals mx minus x1. And really, you just take the x and y and switch them. So y, it's a positive 6, so it's going to be a negative 6, equals my m is my slope. X, it's a negative 2, so it's going to be a positive 2. A line passing through those points in standard form. So this one's going to take a little bit more room. So I might have to go off and write on a different page. But for this one, I'm going to start over here to get my slope. Negative 1, 3, negative 2, negative 4. That goes down 7, minus 1. So negative 7 over negative 1 gives me a positive 7. Now I want you to think about it. If my slope is positive 7, 7 times negative 1 is negative 7. How do I get to 3? I would be plus 10. Let's make sure that works again. What's 7 times negative 2? That'd be negative 14. If I add 10, do I get to negative 4? Yep, so it works. If you're unsure about how to do that, you can always set up a table and solve for b. Now I want standard form. That's ax plus by equals c. My x and y need to be together, and my x needs to be positive. So I'm actually going to move my x over, and I'm going to get negative 7x plus y equals 10, but I want my x positive. So I'm just going to switch everything. Which is technically like dividing by negative 1. C says a line perpendicular. That means flip and switch. So if my slope is negative 3/5, to flip and switch, it's positive 5/3. And I want this point. So y, it's negative, it's going to be positive 3 equals my m, x, and it's negative 1, it's going to be a plus 1. Alright, next one says a line parallel to 4x plus 3, and it contains that point, but this time it wants it in slope intercept. So parallel means same slope. And so I have this point, so I can do this two ways. We've kind of already talked about one of the ways. But I can do point slope form. Y, it's opposite, so it's minus 1, equals 4. X, it's negative, so it's going to be positive. And then I can just solve for y, because I want it in slope intercept. And that's y equals mx plus b. So then I would, if I distributed, I get y minus 1 equals 4x plus 16. And then add 1 to both sides. So I get y equals 4x plus 17. Again, the other way is you could just think to yourself, what's negative 4 times 4? That's negative 16. How do you get to 1? By adding 17. How do you write each of these equations? A horizontal line is hoi, and its y equals, well, what is my y equal here? 4. A vertical line is bucks. Its x equals, what's x equal here? Negative 2. Write an equation in slope-intercept form for a line perpendicular to this and containing this point. Alright, so I need to solve for y just to find the slope first. This was just like it was on our quiz. And then if I divide by 2, I get y equals negative 3/2 x plus 4. Well, perpendicular, remember we said, is flip and switch. So if I'm at negative 3/2, to flip and switch, it's going to be positive 2/3. I want it to go through that point though. So it's going to be y minus, it's going to be a negative 4 equals 2/3 x. That's positive, so it's going to be a -3. Oops, I'm taking up a lot of space. So I want it in slope-intercept form. That's y by itself. Then I just need to solve and get y by itself here. So when I distribute, I get y minus 4 equals 2/3 x minus 2. And then if I add 4 to both sides, I get y equals 2/3 x plus 2. All right, these last ones, I'm not going to really go over exactly all the answers. I'm going to show you my key. But remember converse, well, let me just show you this real quick. Converse means to switch. Inverse means adding not. And contrapositive is switch and not. The biconditional is if the converse, if this is true and this is true, then it's a biconditional. So for this first one, that's a no. For this one is a biconditional, so the way you would write it is two angles are supplementary if and only if are supplementary and congruent. Sorry, I didn't see that. If and only if they are right angles. And on the bottom, a quadrilateral has 4 congruent sides if and only if it is a rhombus. Now, I didn't expect you to get this one only because I know some of you think that's false because of a square. We'll talk about that in that unit, but a square is a rhombus. But I just want to make sure you get the idea. It's okay if you got that one wrong. Again, here's my key for all of those. You can pause the video and check your answers. Feel free to ask questions on Remind. And good luck on your test tomorrow.